I hope you are having a great time at KubeCon and enjoy some interesting sessions over the last 2 days. And I'm hoping today you're going to enjoy the same. Thank you for joining me today. Kubernetes is complex and it takes a lot of challenges to build something behind the scenes. And one of the components that is actually using that is Linux Cgroup, the backbone behind the container resource control that limits and prioritizes CPU, disk, and memory. If you ever wonder why your container gets killed despite setting the memory limits, or why CPU gets because of thing where you feel like it's getting out of control, you might be come across thing called Cgroups, which is impacting your applications. So in today's sessions, we're going to talk about something which is really important for someone who is working with Kubernetes, that is transition from Cgroup v1 to v2. That shift will impact the resource management, performance, and the resource control and the workload compatibility. So a little bit about myself. My name is Sohan Kunkerkar. I work at Red Hat as a senior software engineer. I'm one of the CRI-O maintainers and a member of SIG-Node, which works predominantly on kubelet and node specific projects. If I'm not working, I'll be either playing flute or enjoying trekking and outdoor activities. So here's the agenda for today's talk. We'll be covering the first part where we'll talking about the foundation of Cgroup, followed by the migration process. And in the second half, we'll talk about the impact while doing the transition and think about the future outlook. So can I get a quick show of hands? How many of you are using Cgroup v2 in their production clusters? That's good. And how about v1? All right. So with this talk, my intention is towards the end of this session, I can pursue towards moving to v2. So let's get started. So before that, I want to make sure that we are on the same page. So we'll quickly touch base on what is Cgroup exactly. Cgroup is a Linux kernel feature that manages the system resources. So you can actually see, you can control the CPU, memory, and disk I/O for the process. Cgroup, you can imagine as it can actually impose the limit on the resource usage. At the same time, it can monitor the performance of the group resources, and also controls the scheduling and prioritization. One of the important part of Cgroup is it doesn't allow any single process to hog up the entire resources, and it also has it controls the process isolation, and it also helps in performance optimization. So we leverage these Cgroups in a multi-tenant environment such as cloud computing or container-based deployments. So let's understand how Cgroup was there. It started with v1, and you can find the Cgroup file system under sysfs Cgroup. So there are a bunch of things there. You can find subtrees under the Linux process, and the Linux community started with v1, where it was pretty basic with basic resource management, where you can see on the screen where you will have each resource will have a bunch of subtrees. So the thing is here. This can lead to complexity when managing the multiple resources, and that's where Linux community came up with v2, where you can see here it's a unified one and a constant interface. So in this structure, all resources come under the same unified hierarchy, and which definitely helps in resource management and monitoring the processes. So let's understand. Now we know we have two versions. Let's understand the limitations of v1, and we can then talk about the shortcomings that are addressed by v2, and then the couple of features that are introduced with v2. So with v1, what's really happening is it has multiple independent hierarchies. So in Cgroup v1 controller, each resource type has, like the CPU, memory, and I/O, is managed by separate hierarchies. So this creates added complexity for admins who wants to really manage the resources and want to configure certain things. But because of each resource hierarchy, it would be difficult for someone to actually manage that, and it might lead to some misconfiguration. The second thing is lack of coordination among different controllers. So controllers like CPU, memory in Cgroup v2 operate independently, and making it difficult to coordinate across, effectively across different things. And that's where it leads to performance problem under heavy load. Third thing is about inconsistent API design, where the API in Cgroup v1 lacks consistency. And there are a couple of attachment rules for the processes, which is really difficult to follow, and that might lead to confusing in the management and error prone. And last but not the least, as the number of C groups increases, Cgroup lacks, Cgroup lacks the scalability, because it manages, each resource will have its own hierarchy. At some point of time, it's going to get bursted because, as the number of pods increases, it cannot handle that particular resources. And in order to solve this issue, we, Linux kernel community came up with Cgroup v2, where with its unified hierarchy, it not only solves the better utilization of the resources and pressure handling, it also helps in enhancing the memory and CPU controllers. Now, apart from shortcomings, Cgroup v2 also has a couple of features. I'm going to name two. The first is thread mode, where it allows individual threads to create a separate Cgroup, with which you can actually set the CPU and memory limits for a thread instead of the entire process. And the second is explicit delegation. So in explicit delegation mechanism, you are granting control over, over a subtree of the Cgroup to a non-root user. So what really happens in that case, it basically allows you to have a securely and confidently you can delegate that without losing the system stability. Now let's understand Cgroup in Kubernetes, but before that I want to kind of walk you through this timeline and how Linux kernel started with Cgroup v1. So they introduced that in 2008 with Cgroup v1, and then in 2016 they came up with Cgroup v2. If you see Kubernetes timeline, Kubernetes was born in 2014, where we started v1, and it took us like almost 6 years to go to v2. So the idea behind this timeline to make you realize that Cgroup v2, though Cgroup v2 was stabilized in 2016 in Linux kernel, Kubernetes ecosystem took some time to soak that change in Linux kernel before pulling that into kube releases. So you could see here, like 2020 we started. Kubernetes has its own way of graduating features, let that be Linux feature or any feature. So we started with alpha, then beta was there in 2021, and then 22 we went with GA. And subsequently, container runtime support also started supporting Cgroup v2. So the idea behind this particular slide is to make you realize that it was a cautious decision to make sure that we get the best features with stability. Now let's understand Cgroups in Kubernetes. So Kubernetes rely heavily on Cgroups to manage and isolate resources consumed by containers in pods. So besides being a Linux primitive, Cgroup is the basic building block of containers. So you can think of this as without Cgroup, there is no containers. I'll explain you in detail as to what I'm talking about. But before that, let's discuss how Kubernetes actually leveraging some of the features from Cgroup. The first one is resource allocation. So Cgroup ensures that containers do not exceed their CPU and memory limits. With isolation, it isolates isolates the containers from each other to make sure it has a resource contention. And last but not the least, monitoring, where it tracks the resource usage to make sure we get the insights and metrics. We can do that with CAdvisor today, which is already integrated with Kubelet. And I will show you one demo after this, where we will walk you through Cgroup's path, and we'll be using this pod spec. So before that, I just want to explain a few things about this pod. As you can see, we are trying to set the requests and limits at the container level. So with this, what Kubernetes is going to do, it's going to create pod inside sysfs Cgroup, that's the Cgroup file system. And inside that, we have this feature called memory QoS, which is still in alpha in Kubernetes. What it does, based on your limits, it will create either burstable pod, guaranteed pod, or best effort pod. If your request and limits matches like in terms of the memory, then it will have the guaranteed pod. If the memory for the request is less than the limits, then it will go to burstable. Otherwise, if you don't mention anything, it will fall under best effort. So let me go ahead and play this video. So in this demo, I'm using Kubernetes cluster with Cgroup v2 enable, and I'm using Cryo as the container runtime interface. So cluster is already running. Let's see the pod spec. I'm almost using the same pod spec with few changes so that it can work on my system. Let's go ahead and create the pod. So it will take some time to get into running state. All right. Now, what we can do, we'll go ahead and use crossroads to see the container ID. So you can see the web server is running with the container ID. So with this container ID, I'm going to use crossroads inspect, and we'll look for the Cgroups path. So it's a JSON file. I'm just going to use a JQ to kind of go through that Cgroups part directly. Yeah. So what really happens here, like you are creating a pod, and you are instructing the node that the pod should get created, and kubelet will basically ask CRI to create pod for you, and kubelet will ask CRI, and CRI in turn gives OCI specific JSON to any underlying runtime. Let that be runs your crun to make sure you create that pod. So that's how when you do crossroads inspect, you will basically see the container spec with all the remittent resources. But for the time being, I'm sticking to only Cgroups path. So all right. So you can see here it comes under burstable pod because the request limit is less than request memory is less than the limit memory. You can also use systemd GLS to see the hierarchy. So you can see here we have a burstable pod, under that we have a pod, and under that we have container. Let's quickly see the systemd properties for a container. So what the system property does, it basically gives you idea what values they're going to set for the Cgroups that are there inside that folder. So I'm going to quickly see that. Yeah. So you can see CPU weight that we're going to see in a bit. And we'll also go inside sysfs to see the exact value. Yeah, so we have those things. And now we will go inside that folder to make sure we have the respective values. So the first one is CPU dot weight, that will give you the priority for it, which is 10. Then we have CPU max, that will give you what we set for the limits, CPU limits for the pod spec. We'll also see memory min. All right, I'm going to stop here. All right, can you see memory min here is 0. So when I actually spin up the cluster, at that time I didn't enable memory QoS feature, and that's the reason it's set to 0. So it doesn't apply the kubelet logic where if it is it falls under burstable, and if you enable QoS feature, then it will do some calculation behind the scene and it will give you some value. But currently that feature is not enabled, and that's why it is showing as 0. And last but not the least, CPU memory dot max. Yeah. All right. So before that, we saw how the resource got tracked. Now let's understand how it get monitored using cAdvisor. So what I'm going to do here is like we are going to hit the URL to see the container specific metrics. So I've already created kubectl proxy behind the scenes. So that ID is already there. I'm just going ahead and kind of querying that. So what you see here is the same thing when you go inside sysfs Cgroup and trying to kind of go through each and every file to look for the values. So this is the easiest way to query any metrics rather than going inside Cgroup files. Right. Cool. So with this demo, let's understand, now we know about Cgroup in Kubernetes, let's understand the benefits of Cgroup v2 in Kubernetes. We talked about memory QoS in the previous slide, but let's discuss what that means for Kubernetes. So it allows for fine-grained allocation, memory allocation. So what Kubernetes does is like it basically prioritizes memory for critical applications. And it reduces the risk for slowdowns or crashes in essential services under high usage. So behind the scene, what it's using is it's actually using memory.min to give guaranteed memory. So if I would have tweaked that with memory QoS, like if it would have added feature get, then it would have given that value. The second part is swap support. So with improved swap support, Cgroup v2 helps us use swap, very effectively. And this also enables us to handle memory overcommitment situation gracefully. So with swap support, you can actually use memory.swap.max. This is only available in Cgroup v2 to make sure you basically use swaps space when there's a problem with memory overcommitment. And this use case, this is normally used in telco cases where you need a swap support in case the memory goes haywire. Then let's discuss about CPU load protection. So CPU load protection is one of the another important feature. It makes sure that the critical processes from CPU overcommitment during heavy load periods. So Cgroup v2 behind the scene uses CPU load balancing to make sure that it stick to the resources what it has. At the same time, it doesn't falls under a CPU overcommitment issue. And with PSI, that's precious stall information, you can actually see and track the metrics, and you can take the scheduling decision on the fly, and that is really important. We basically use PSI and memory.max to make sure we have memory intensive workloads, and that should be properly deployed on Kubernetes. We'll discuss this later in the slide, but I just want to give you that highlight. Then it comes to eBPF based resource management. With Cgroup v2 integrates eBPF based resource management, a lightweight way of dynamically monitor and control resources at the kernel level. So one of the crucial part is eBPF integrates really well with Cgroup v2 because of its unified hierarchy. So it will have all resources will come under the same hierarchy rather than the separate resource will have the separate. So compared to v2 has better hierarchy structure. And last but not the least, but I think I have added one more after attending yesterday's SIG-Node meeting, where Mrinal basically discussed about pod level resources. So I think a few days back that PR got merged, so I'll also discuss that. But before that, nested containers. So Cgroup v2 supports better isolation and management for nested containers, so which is essential for complex applications where it requires multiple layers of containers. I see this also improves the security and resource separation in a more intricate microservices setup. So with this, the last is pod level resources. So in the previous slide, I was talking about the pod spec where we were actually mentioning limits for the container. But in this case, what's really happening is like you can mention limits for a pod instead of mentioning for the containers. So as a user, I don't want to think about containers. I want to think more from the pod perspective, how we are going to set the limits for pod instead of going inside containers and looking for each and every stuff. So that is really important from the user's perspective. And this feature recently got merged, and it's in alpha state probably for 1.32. All right, so now we know about the benefits. Let's understand the migration process, which is very well listed in Kubernetes documentation and blogs. So before you go to before you try to install Cgroup v2 specific stuff, you need to make sure that you have the prerequisites in place. The first one is about the Kubernetes release, like Kubernetes supports Cgroup v2 with 1.25 plus, and you need specific container runtime. You can choose any of the followings. You just need to make sure that it follows the version, and the Linux kernel, which is 5.8 plus. So once you have the prerequisites, the next part is about planning. So in planning, you need to make sure that your node supports the Cgroup v2 stuff. So sometimes we will discuss that later about the infrastructure adoption. But if your node doesn't support Cgroup v2, then you might need to make sure that you need to change the version for OS in order to get in order to make sure you can switch to v2 smoothly. And you need to also audit the workloads. So there's a case where your infrastructure is already on v2, but your application is not supporting v2 specific features. So something like memory.min, memory.max, those features you cannot use because your application is developed in such a way that it utilizes Cgroup v1 hierarchy. We'll also discuss that later, but I want to give you that point. And last but not the least, once you have everything in place, the migration process is pretty much similar to every other things where how you basically introduce Kubernetes change. And once you have that, you just need to kind of verify and see if Cgroup v2 is enabled. I'll not go too much detail into it. All right. So as I was talking about infrastructure adoption, so when it comes to Cgroup v2, it's not just about Kubernetes being ready. It's about the entire stack being ready. Starting with Linux kernel, Kubernetes, container runtimes, systemd, and couple of projects around Kubernetes ecosystem. So when it comes to operating system, Rail 10, which is going beta in few months, already defaulted to Cgroup v2, and there are a couple of other operating systems. We also have Kubernetes distribution who started supporting Cgroup v2 by default, though they have this flexibility to support Cgroup v1 by making few changes. But this is where it stands, and other requirements include Linux kernel and containerd stuff that we already discussed in the prerequisites. All right, these are some of the projects that already support Cgroup v2 by default. Not exclusively, but there are other projects. But I thought like to include this, which revolves around container runtime and kubelet. All right, language compatibility. So someone might ask this question: why do we need language compatibility? Especially for Cgroup. So I'll tell you, let's talk about Java. So Java developers, in JDK, they always look for Cgroup files inside Cgroup files to understand memory and CPU limits for a particular system. So with Cgroup v1 versus v2, if you could see the hierarchy changes, it would be difficult for someone who is building Java application to kind of see the underlying thing. And based on that, if they've made any assumption and if they build application, it would be difficult to kind of deploy that on the platform, because platform is already on Cgroup v2. So there are a couple of languages here which already started supporting Cgroup v2. It's just a matter of version requirements and how you need to configure this thing. So I just want to leave you this with this particular table and make you familiarized with that. I'm not going to go detail into it, but just want to give you this highlight. Now we talked about language compatibility. Let's also understand optimizing workload performance using Cgroup v2. we already discussed memory intensive applications. So for memory intensive, the moment I say memory intensive, it's always about using a lot of memory. So Cgroup V2 specifically offers features like memory.high for fine-tuning memory application. Together, you can use PSI, pressure stall information metrics to detect memory pressure early. So this will help you prevent unexpected performance dip. So if you see here, you can actually use memory.high to set soft limit and memory monitor pressure PSI for early detection of the memory pressure. When it comes to CPU bound application, it uses CPU.max to help you manage throttling more effectively. And together you can actually use quality of service that we already discussed, one of the class, to make sure you set the clear priorities and adjust the resource distribution accordingly. When it comes to IO heavy, with IO heavy you can actually use IO.max and IO.weight, which you could get from Cgroup V2. So you can set the bandwidth limit with the help of IO.max, and you can adjust the prioritization for IO.weight. It's also important for latency specific application. And last but not the least, ML and AI workloads, which is very important nowadays. So Cgroup V2 basically enhances hierarchical control over the device access and prioritization. So this is critical for high performance scenarios where GPU and other resources must be managed precisely. So with this information, let's talk about impact on Kubernetes ecosystem. So let's understand the stakeholders involved in this, and I really want to make you understand what's really happening in the background, because as users like the application developers, SREs, or the end users, probably that is something which is like an abstracted level where they don't know what's really happening. So I want to give you some summary as to when any feature goes into Kubernetes. This is how it works, where the application developers or SREs, they try to test that feature. If something goes wrong, they collaborate with Kubernetes developers. End user customers, they also have some feedback, they also go with the same. And kernel developers, Kubernetes developers basically sync with kernel developers if they have any technical understanding that they want to clarify regarding the kernel feature. So if you see here, the core part of the entire workflow is the Kubernetes developers, and onus comes on them because at the end of the day, they want to maintain two versions, V1 and V2. So it's not about maintaining two versions, it's about fixing those, patching those, addressing the CVEs. It's a heavy burden, and if anyone knows about it, Linux kernel community already not maintaining Cgroup V1. So they haven't deprecated it, but they are not maintaining Cgroup V1 specific features at all. So something is happening behind the scene. It's Kubernetes developers, they are making sure that they are doing stuff at the Kubernetes level and not at the kernel level. So with this, let's understand the challenges. So there are two types of challenges here, the user specific and Kubernetes maintainer specific. Let's stick to user specific. The first thing about this is complex dependencies. As you might aware, once you have large applications with Cgroup V2, Cgroup V1 specific behavior, it would be very difficult to migrate that. And one of the reasons behind that is like a change in the behavior. I'll talk about that where, later in the point where, there's a point where behavior changes. And that was one of the point where people don't want to move to V2. Then user adoption barriers. Sometimes users might be very comfortable with Cgroup V1, and that's where they want to move to hybrid setup. So there's a case where I was going through one of the blogs where the Java developer was talking about things where they are having Cgroup V1, V2, and they basically backported some of the features from V2 to V1. So ultimately, they are using V1, V2, and combination of V1, V2, which is working for them, but it's not sustainable in the longer run because every single infrastructure stack is moving towards V2. So this is something which we need to address early, because at some point of time they might be in a situation where they'll face the issue and things would be a little complicated. Then the behavior change. So I was discussing about it. So let's say user is on V1, they move to V2 like through cluster upgrade. Now in Cgroup V1, how kills work. Like in Cgroup V1, when one process gets killed, when one process inside the container gets killed, other processes are still running. However, with Cgroup V2, it has a unified hierarchy. The moment one process gets killed, the entire container gets killed. Now, here is the PR which got merged last week, where what we are trying to do is like we are trying to match, they already moved to V2, but we are trying to match V1's behavior in V2, which is strange, but at the same time, I can understand from their perspective that they want to support users at some point of time, but this kind of stuff will not help and not sustainable in the longer run, because when someone moves, like if the infrastructure moves to V2, they have to switch their infrastructure to respective version. And last but not the least, that we already covered about application not optimized for Cgroup V2 may face unexpected behavior and performance issues. So with this, let's discuss also about Kubernetes maintenance. So that is something that comes on Kubernetes developers. I'm not sure how many of you are aware about Kubernetes test infra. We are actually maintaining two versions. Like there are two equal coverage for both V1 and V2. So there are set of jobs. One runs for V1 and second for V2. And since we are moving towards V2, I think making that investment in running V1 specific jobs is not sustainable. Though Kubernetes has not deprecated V1, but at some point of time they're going to do that. And last but not the least, legacy maintenance. So this point is more for downstream Kubernetes distributions, where their customers are still on the older versions and they want to support Cgroup V1 specific stuff. Because for upstream, anyway, we do EOL, and I think it's already got EOL 1.25, but yeah. All right. So future looks really bright. We already started. The first thing that we did was Cgroup V1 into maintenance mode with Kubernetes 1.31. So what does that mean for user is like, we are not going to develop any new features, though we are going to fix the security issues, but there's no assurance on fixing the bugs. There is also a plan to deprecate Cgroup V1 sooner. I was supposed to mention the date, but there are a couple of things. Let's say the first issue about runtime spec. There we are discussing about synchronous announcement across different projects to make sure that if someone is on one version, they should get that announcement and they should move to V2 to make sure that they don't break anything unknowingly in the production environment. And third point is about identify the stack changes. So yesterday itself, SIG release master node job for Cryo was failing. And one of the reasons for that is underlying system was using Fedora 40, Fedora CoreOS 40, and it moved to Fedora CoreOS 41. So what Fedora does is like with Fedora 41, they are no longer going to support Cgroup V1. Even with the kernel line argument, the only way to support V1 is through systemd environment variable. That's like a hack around, but that was the issue. And at some point of time, we need to think like how we want to proceed and how we want to fix this stuff. And last but not the least, we need to publicize the feedback about transitioning to Cgroup V2. Now, I don't see that happening, but like probably that happened for Kubernetes in general, but probably we should start having that information about V2 specific, like let's say user is actually doing some testimonials. That way, they will get some confidence in V2 and they'll start moving towards V2 in future. All right, I'll just conclude this with, as we wrap up, I want to emphasize our confidence on Cgroup V2's potential to manage advanced workloads. So tooling and collaboration happens across different Kubernetes projects to make sure we have that integration in place. And we are also trying to have refinement in place to make sure we boost workload and compatibility and observability. So with this, those who are on V1, I'm hoping this presentation help you understand what's really happening behind the scene. And I'm going to assure you like what really happening. And there's a thing where, moving to V2 is not only beneficial for your projects or products, but it's also beneficial for the larger ecosystem, let that be Linux or Kubernetes in general. So with that, I will leave you with this picture that really depicts what the choice you have, like whether you want to stick with Cgroup V1 and be in the darkness, or move to Cgroup V2 and be in the sunshine. With that, thank you so much for attending this talk, and yeah, I'm open for questions. Any questions?
Yes. Hello there.
Yeah.
So first of all, thank you for wonderful talk. This was really good. I have several questions, and one of them, on your slide, you mentioned that for Red Hat 8, the support is optional, right? But maybe it's a silly question again, but if we look at the kernel version there, it's kernel version 4, right? And these features for Cgroups V2 are for kernel version 5.
Yes.
So this means that it's some kind of limited support in Red Hat 8?
Yeah, I think, so I pulled that information from Kubernetes guide itself, where with 4. Like whatever that version is, there we have limited support with Cgroup V2, but with 5.8 we have like the full, the GA support where you can, easily move and without any problem, probably on the production clusters.
Okay, thank you. So this is the first one. The second question is about swap. So I was also attending yesterday the SIG discussion, and they were saying that it's kind of not yet ready because of the eviction manager integrations that they're doing. Could you provide any brief insight, like what is the challenge that they're facing, like on that front? Is it like, when to decide when to evict and when to OM kill and when to move to swap? Like what is
Well, we are still discussing that detail in the SIG meeting. Probably I don't know the exact nitty-gritty, but we can discuss it probably after this session.
Okay,
for sure.
Okay, thank you.
Yeah.
First of all, thank you for a great talk. You went into quite a detail. So you mentioned with Cgroup V2, with memory.max and memory.swap.max, you have the option of, can we oversubscribe memory across all our pods on a node, kind of how you can do with CPU, and not run into kill kind of issues with that?
But how will you achieve that? Probably need to do that at the kubelet level. But if you have, you can easily use Cgroups controllers to, to control that stuff. Why do you want to kind of do that at the kubelet level and try to force it?
So basically put more pods with some total memory more than the node has available, and it should be able to manage it with swap, assuming swap's enabled. Maybe.
Swap, yeah, I think that's an interesting question actually, but I'm not sure on that side of things. Okay. Probably need to discuss that, but there's a chance we can do that, but yeah, I'm not quite sure.
Cool, thank you.
Yeah. I think we are on time.
On your one slide, you mentioned about the umkill change PR that I think you said it was just pulled. Is that going in 1.32 or?
That was 1.31. So Cgroup V1 is going in maintenance mode, which means
the change order you're talking about, the difference in umkill between V1 and V2, and you said that there's one PR that maybe was back.
Yeah, so it recently got merged into main branch, so probably it will come in 1.32 for sure.
1.32.
Yeah.
Thanks.
Any other questions? Probably. I'm out of time. Thank you.